Okay, we are going to discuss similar triangles. So the word similar means they're almost the same, but not quite the same. And this is all going to be based on them being proportional. So if something's proportional, it means you've got like a small version and a larger version, but they have the same shape. They just have different sizes. So like you've got this triangle and this triangle. They're proportional. Well, they're not because I'm a terrible artist, but they're proportional because they have the same basic shape versus something like this and like this. This is not proportional. These are not the same shapes. These are the same shape. You just have a small and a big one. So that's what we're looking for. Now, you should have in front of you some notes that look like this. Okay, so triangles that are similar are the same proportion, but not equal. So they are not equal. So let's take a look at some examples here. So remember, these arcs that we draw in the corners are telling you about the size. So here we have triangle A, B, and C. And then we have triangle D, E, F. So triangle A and D are both marked with one arc. That means that they are the same angle. Like let's say that means they're both, I don't know, some number. Let's say they're 40. That one arc means they're the same. So then angles B and E are also the same. Let's say they're 60. And then we can also see that triangles C and F are the same, so that's going to make them be 80. And I know they're the same because they have these 3 arcs here and 3 arcs there. That's indicating to me that they are the same. However, their sides are not the same. So 7 and 14, like these are corresponding sides. So A and C corresponds to D and F because they fall in between arc 1 and arc 3. See, arc 1, arc 3. Then you've got side BC corresponds to EF, and that side's 6 and 12. So you can see a pattern here. See, we've got 7 to 14, 6 to 12. So they're doubling. And that means, like, let me set that up. So let's call this triangle 1, and we'll call this triangle 2. So we can set up these, what we call ratios here. I don't want an equal sign there. About T1 and T2. And a ratio looks like a fraction. So if I focus on this bottom side, AC, that's 7. And it corresponds right here with 14 for T2. And then over here, AB is 10. And so if I want to know what's happening with DE, I can figure that out because they're going to create a ratio, right? And furthermore, it'd be really helpful if I could write the right thing because that's not a 17, that's a 14. Okay. So look what's happening. You've got what happens here to go from 7 to 14. You're multiplying by 2, which means this is also going to need to multiply by 2. So therefore, that x has to be 20. So we know that this side is 20. And the reason we know that is because these are similar triangles, and they are similar because they have all the same angles. So having the same angles as another triangle means that they are similar. Another hint that they are similar is that they have the same proportions. So this doubles to 14. This side also doubles to 12. That shows us that they are proportional. This is how we set up proportions right here. We'll talk about that more later. Another way these often look is like this. So here we've got 2 triangles happening. We've got ABC. ABC is the big triangle. Triangle ABC. And it's the big one. And when we look at triangle ABC, we ignore this DEF. So we've got triangle ABC. And then as part of triangle, and within that, we've got DEB. So there's a second triangle in here, triangle DEB. These are proportional because they're drawn together. They share angle B. So I could draw an arc there. That means they're the same. Now angle C has to be the same as angle E because they're built into the same triangle. Same with angle A. Angle A and angle D have to be equal because they're built, the triangles are within each other. So therefore, these two triangles are similar, and I know that because they share angles and they have all matching angles. Okay, so we need a way to write that, and the way we show that is we would say triangle A, let's say ABC, and we do one squiggle line is similar to triangle DEF, or whatever it is we're doing. This squiggle means similar. We don't use an equal sign there because they're not equal. They're similar. They have the same angles and proportional sides. So let's see what this looks like. Let's do some practice down here. So, all right, so here we can see that we've got triangle on the outside ABE. So triangle ABE. And it's going to be similar to our inside triangle, which is CDE. So that's similar to triangle CDE. It wants to know, the question is, what is the side of angle AE? Well, to do this, we're going to set up a proportion. So I'm going to put my big triangle on the left, an equal sign, and my little triangle on the right. So actually, I'll move this over here and then we'll be able to kind of see. So I'm going to talk about A, B, and E on the left side and C, D, E on the right side. Okay, so we're going to set up a ratio. So let's look at two things we know. So on triangle ABE, we've got this 15. So I'm going to put that number on top. And then what is the corresponding side to that? It's CD, right? Right here. And that is 10. All right, well, we are looking for this long side, this long side here. I don't know that side, so I'm going to put that on the bottom, and I'm going to call it X. It corresponds with, from triangle CDE, it corresponds with this, with side CE, which is 12. So now I've set up a ratio, and based on this, I can solve for X. I can use algebra here. Right? Like, I know how to do this. And actually, I can even make my life a little bit easier here, and I can turn this whole situation upside down, kind of like in sine law. It doesn't matter what's on top as long as they're both on top. Like, do you see how here I've got the X and the 12 on the bottom, and here the X and the 12 are on the top? That's all that matters, as long as their corresponding parts are on the same piece. So now this is just algebra. What's 12 divided by 10? You're going to find that out. 12 divided by 10 is, 1.2. And that equals X over 15. Well, how do you solve for X? Move your 15 over. X equals, what do you get? You get 18. So that means that this full side must be 18 because they're similar triangles, so they have to share a proportion. Let's try this one over here. So we've got 3, 4, 5. And here we have question mark 9 and 15. So first of all, determine if they're similar. They are. They have the same angles. Now, let's look at corresponding sides. So this side and this side are the same, right? And this side and this side are the same. And this side and this side are the same. So in order to find this question mark, we have to set up our ratios again. So I'm going to start with this triangle, and I'm going to choose this 4. All right, so I'm going to put 4 on top. That means that its corresponding one's going to go over here. And then I've got this 3 on the bottom, so that 3 is going to go here. And that corresponds with the 9. So again, now we're just solving for X. So you're going to say 4 divided by 3 times 9. And that's going to give you your answer. And if you do that, you're like, okay, what's 4 divided by 3? And you've got 4 divided by 3. And then you're going to multiply that by 9. And you get 12. X equals 12. All right. And that's it. That's how you figure out problems with similar triangles.